Right, now let's get started by looking at the origins of the agile design process. So this started in the car industry, actually, in Japan. Let's look at the notes. Here we go. Agile software development. So first of all, why did something new arise? The agile approach. We'll have a look at the problems with the old way of building software. And we'll look at lean software development. So the old way of doing things was called the waterfall model. And the reason it's called waterfall model is that it's like a river with a series of waterfalls. And so you could happily go up and down the stretch of the river, but if you went over the waterfall, that's it. You're on a new stretch of river and you couldn't go back up to the first stretch. So there were four main steps. Analyze the problem, find out what the users wanted, then design the system, then build the system, and then deliver the system. And each step had to be completed before the next step could be started. And once you moved on to the next step, then you couldn't go back to the original step. So once you finish the analysis, that's it. Analysis done. You then go and design the system based on the analysis that you'd completed. Now, each step produced a lot of documentation, and often different people did different steps. There were professional analysts that did only analyze problems, professional designers, chief architects and titles like that who designed the system. Then there were developers who built the system and so on. So there's quite a fragmented team and lots of different roles. So they needed a lot of documentation to record all the decisions made and to coordinate people. And these programming teams were quite large, so they might well be around 100 people or more. And projects took several years to finish. So the problems with the waterfall model: it's difficult to keep all the documentation consistent and up to date. That's one problem. It's unrealistic to assume all the decisions made at the start of the project are correct. So projects are learning processes. As you work through the project, you learn more and more about the problem you're solving, and then you find better ways of doing it halfway through, or issues with your approach can arise some way down the line. So the waterfall model didn't allow you to go back and change your initial decisions. In practice, you had to. And so you had to go back and retrospectively redo all of the documentation to pretend that you'd taken the right decision at the start. Another issue was the customer didn't see the final product until several years had passed. So the customer so it was very important that the customer was right at the very start, and that was very hard to get right. And so therefore there's lots of documentation needed, so the customer had to sign off on their requirements, so that when the system was delivered, the customer probably realized then that they'd asked for the wrong thing, but that's what they got, what they'd asked for originally. There's no way of changing that because they'd signed on the dotted line. Now, that wasn't the only way of building software. Some approaches did a lot better. Unix, for example, was built by two people. And so they built an operating system that's now called Linux, and it's been going for over 40 years. Invented by two people, and as a tool to help them write the operating system, they invented the C programming language, which is the father for many modern programming languages. I mean, C is still used quite a lot for systems programming, and it's given rise to C++ and Java, for example, to follow-up languages that are very similar, but built on C. Right, so a new approach was needed. So The new approach had to be quicker, easier to change, so it had to manage change properly. It had to provide early customer feedback so that the customer knew what they were getting into. And so if they wanted to change their mind, it's a lot cheaper to do that earlier rather than later. And allowed effective monitoring of progress so that projects don't seem to be going fine until rather too late to change them when big problems arise. So a new approach was needed, but the change didn't come from the software industry, but from the car industry, which also needed to make changes. Right, and so what's the aim of the Agile process? To spread decision making over the length of the project. That's another way of saying you don't know everything at the start. You must have a process that allows you to change your decisions as you go. Then balance the communication between users and developers. So in the waterfall model, the users got a say of what they wanted at the start, and that was it. And then the developers went away and did what they thought the users wanted. Now, if users dominate the process, they tend to demand a functionality that can't be delivered. So developers need to keep them honest there on what can actually be achieved. If developers dominate, they lose the opportunity to learn what the customer really needs, and they can end up building a system that the customer didn't want. So communications need to be improved, reduce paperwork. So in agile processes, the code is the main source of documentation. So documentation has a lot of problems, or too much documentation is. One of them is keeping everything consistent. So if you make a change, then there's lots of documents that have to go and be edited. And typically, if there's a lot of documentation, no one keeps it up to date. And having out-of-date documentation is worse than not having the documentation at all. Okay, so it started with cars, and so we'll look at lean software development, which started as the Toyota way. So this all happened in the 90s, where there's a time of change in many areas. So agile processes arose not just in software, but in many manufacturing processes. So producing cars, for example, there's a long design between the initial idea and the delivered product. And so that needed to be shortened. Existing processes were excessively bureaucratic, so that meant it's very difficult to change decisions once they've been made. And assuming that no changes will be made during the lifetime of the project and all initial decisions are right is unrealistic. And so in the 90s, the way of building cars changed, led by Toyota and then followed by all the other major car manufacturers. So compared with buying cars in the 90s, buying cars these days, the cars are better, they last longer. Back in the 90s, if your car was still running 10 years after it was built, then you were quite lucky. Nowadays, you'd feel a bit cheated if your car gave out before 15 years. And you have a reasonable expectation that they'll last for 20 years. Cars are a lot cheaper now than they were in the 90s, and also they're a lot safer. So back in the 90s, the feeling was that safety didn't sell, but they were proved wrong. And so customers demanded safer cars, and safer cars were produced. So the industry listened to the customer a lot more there. So that was the manufacturing, cars just being one example. The software industry was evolving, and starting in the 80s and then into the 90s, object-oriented programming became widespread. And so this was a new way of writing programs that a single programmer could understand much larger programs. And so there's object-oriented programming was the start. So new object-oriented design paradigms were needed to provide an appropriate framework. So a lot of different approaches were tried, and leading to the agile approach, which is quite important these days. So what does lean software development do? Let's look at the principles here. So there's lean development, but as applied to software. Okay, so lean development was the CARS one. Lean software development transferred the ideas to software. And around 1990 was when this started. So there are 7 principles, and these principles apply to most agile approaches. First of all, eliminate waste. So everyone wants to eliminate waste, but still many processes are wasteful. So how can we do that in a sensible way? Amplify learning. So yeah, I mentioned that. Learn as you go during the project implementation. Decide as late as possible. So if you don't really know exactly what you're doing at the start, then don't make hard and fast decisions that are difficult to change. Decide as late as possible. Deliver as fast as possible. So you want quite a quick, fast turnaround so that you can get customer feedback. And so deliver as fast as possible. Empower the team. So instead of having a hierarchical team structure with one boss, you try and make the most of all team members' abilities. So this was a move away from a team made of lots of different specialized roles to a generic developer role in the team. Build integrity in. That's an interesting concept we'll look at in a minute. And see the whole picture. So eliminate waste. What is waste? Waste is non-value adding work. So work you do that doesn't actually make a difference. So eliminating waste is an iterative process. You've got to identify the waste, find out the source of the waste, and then eliminate the source. So it's an ongoing process. So this is the amplifying learning things. The idea is that you don't know all of the answers at any one time. You're continually learning. So continual improvement. So the main source of waste in software projects is excessive documentation, especially in the waterfall approach. And so that's removed in the agile process. Management bureaucracy can also cause waste, and so bureaucracy is minimized. But some things that look like waste are not waste. So for example, throwaway code for experiments. A lot of times if you build software, you have a go, produce something that looks close to the working example, and by doing that you've learned what you really need to do. So you throw that code away, it never makes its way into the final product, and then you code it up a second time for the real code. So that first bit of throwaway code is not waste, because the value it added is learning what you really need to do. So throwaway code for experiments, by and large, is a good thing. Amplify learning. This just says, as I said before, that you're never at the stage where you know everything, and you're continually improving. So everyone shares in the learning process. It's not just something that the team manager learns. And the way to do this in an agile approach is to have short iterations. So writing code is not sitting down for several months at a time until you working on a spec and then produce some final code. Typically you'll code for 2 weeks and you finish a small segment of your problem, and then you have a review at the end of the 2 weeks and you reflect on what you've done. learning what you've done, and then you'll start the next 2-week cycle. So that is there to amplify learning. And developing prototypes and showing them to the customer early makes it easier to learn what's required. So I'll talk about this later on, what is a prototype, but you can see the advantage. A prototype very basically is it's not the real product. It does some aspects of the product in a way that you can show to the customer. So it might be all of the screens in an internet project, but with none of the functionality behind them. And that way the customer sees what the look and feel of the product is going to be like, and so then they can change things then before any real code has been written. Decide late. So keep all options open by putting off decisions as late as possible. Now, this is a dangerous thing to do. So it's very easy to put off decisions forever, never making a decision. So deciding late has to have a process that forces you to actually make decisions. So at the end of the day, the project process is all about making decisions as we go along, especially the management of projects. So the iterative approach means that we've got a 2-week iteration, then you have to make decisions at the start of each iteration, and then you get to decide, get to find out if they're any good or not within 2 weeks. Decide late, that's how it's done. You have to make some decisions, and planning meetings consider all the different options. Options are costed and the best one chosen. So you have planning meetings at the start of each iteration. Now, what if you really can't decide something? Say you've got 2 different ways of solving the problem or building the software, and you've no idea which one is correct. Now, there are two ways that this might arise. One way is that you've got 2 different ways of solving a problem, and they're both quite different, but they'll both solve the problem but in different ways, and you're not sure which one to take. So one approach is set-based design is to do both of them and then see which is the best after 2 weeks or so. So this might seem like waste, but this has the value added finding the best solution. So if the best solution is going to make a big difference to the final outcome of the product, then we might as well do 2 experiments in parallel and pick the best one. Now, the other way that it might be difficult to make a decision arises is if we have 2 approaches that are very similar. And unfortunately, this is a very common aspect, a very human nature-ish. The smaller the difference between 2 different opinions, the louder the argument between proponents of each one. So you've got to recognize this situation. If the difference between the 2 approaches is very small, it doesn't matter which one you take. Toss a coin if you have to, but don't spend ages and ages splitting hairs and arguing about unimportant points. So, okay, set-based design is useful if there are 2 different approaches that you don't know which is the best, and so then you can do them both. Deliver fast. This is important in the internet age. Usually the first product in a new area will win and get the market share, even if it's not very good. So time to market is more important than quality of the product. But obviously, if 2 products both get to the market at the same time, then the best product should win, hopefully. So delivering fast, short iterations produce usable code quickly. So the idea is you have your 2-week iteration. At the end of the 2 weeks, you have a usable piece of software. So that gives the gives you the opportunity to produce a release quite quickly if you need to because of market conditions. Getting first to the market is difficult to maintain quality as well. So that's a nasty trade-off that you often have to face up to, in that it's more important to get a not very good product to market first, if that's what the market conditions say. Right, so set-based design does enable us to deliver fast because we're trying two different options exactly at the same time rather than one after the other. So we put more effort into it for a shorter elapsed time. So what do I mean by effort and elapsed time? Let's have a little detour here. Cost, effort, and elapsed time. So effort is a technical term. It's the total amount of developer time spent on the project. And it's measured in ideal days. So remember when I said earlier that I worked with Fred Brooks and his seminal book was The Mythical Man Month. So that was the waterfall era. And back in those days, you measured the amount of time a programmer spent in months. So the man month. With an agile approach, you measure it in days and not just calendar days, ideal days. I'll tell you what an ideal day is later. All right, it's a simple idea. An ideal day is, imagine you have 8 hours where you do nothing but programming. So that's an ideal situation. In reality, you'll have to do other things like answer emails and the like. So a week of 5 days will typically contain 2 or 3 ideal days worth of actual work. So that's the effort. It's the total amount of developer time spent on a project. So we've got 5 developers. They work on a project and each of them is working full time, which equates to only 3 ideal days per week. And they work for 10 weeks. And the effort is total number of ideal days. 5 developers, 3 ideal days per week. That's 15 ideal days per week. Do it for 10 weeks. So that's 150 ideal days. So that's the amount of developer effort that's needed on this project. Elapsed time is how long the project takes. So 10 weeks in the above example. So if we had more developers, the effort is exactly the same, then we'll get it finished in a shorter amount of time. But there's a limit to how far we can take that. So again, I'll talk about that later. So that's effort is the total amount of programming time. Elapsed time is time from start to finish. The total cost is, you might think the developers' wages will be the cost, but there's also other additional costs. So the total cost includes other stuff. So what else do we need? You can't just have developers working all by themselves as the only people in the company. You'll need managers, salesmen, marketing people, HR, secretaries and the like. So all of these are called unproductive labor costs. So that's the technical term. They are productive, they're just not producing code. Then there's capital costs, interest on borrowed money, and then there'll be accommodation, equipment, and stuff like that. Right, so that's a little diversion on cost, effort, and elapsed time. Let's get back to the principles. Team empowerment. So the role of the manager is not to tell people how to do their jobs. The idea in the Agile approach is you find capable people, let them do their jobs. And in fact, a team manager's role is to remove obstacles that prevent people from getting their work done. Now, this raises interesting questions. Ideally, if you want to form your ideal team, you'll pick experienced people. And so typically job adverts say requires 2 years experience in the software industry. So ideally, but how do novices become capable? How do people get 2 years experience? So you can't only employ experienced people, or everyone can't only employ experienced people. So there are several different approaches here. We could let other companies train novices, and we only employ people once they pass the novice stage. So that has its attractions, although that's an unsustainable approach that not everyone can take. So eventually someone has to hire novices and train them. And so the manager is then a mentor. They have to develop novices and help them to improve their skills. But that's an interesting aspect that I'm sure you'll discover when you get out into the IT jobs market. Now, human resources is a horrible term that treats people as interchangeable resources, but people are not, they're individuals, and the Agile approach tries to treat people as individuals, and company procedures should reflect this, and it's also the role of the manager to get the best out of each individual's ability. Now, another approach here is self-organizing teams. So the team should be able to work by themselves without a manager telling them what to do. Now, there's a limit, a natural limit on the size of teams that can do this. And rule of thumb is it's less than 10, say around 7 people in a team. Once you get more than 10, then you start to get little cliques, and it's difficult for the team to function function at its best, and they need some sort of middle management structure. So we're going to assume that we'll have small teams for the start of this course, but towards the end of this section, we'll look at different management techniques for scaling up so that we can have more than 7 or 8 people working on a project. Inbuilt integrity. So there's several different aspects of integrity of the product. So architectural integrity, this means that the design is simple and the design is complete at all times. So we want to keep the design simple, and that's actually going to be quite challenging. So when we start a project, we have an idea of how we're going to build it. And so our initial design is going to be nice and clean and good. But as we go on, we'll add stuff to it, and eventually the integrity will get compromised. So this is also conceptual integrity. So this is how the lower level pieces fit together. And so the integrity tries to make sure they all fit together well and in a natural way. So this leads to something called refactoring that we have to do regularly. So I'll have another diversion about that in a minute. Product integrity. So the product has to work and be good. And by and large, this is achieved through thorough testing. And finally, perceived integrity. It's not good enough to be good. It's not enough to be good. We must also be seen to be good. So how do we make sure that customers and other external people realize that our products are good? So this diversion to refactoring, what is it? Well, when we build our code, we'll have classes and methods, and they'll all be related to one another. And code users, people who use other people's code, know and understand the method heading, so they know what they need to do to call other people's code. So to do this, for the code to have integrity, then we need an overview of the code structure, ideally a one-page class structure diagram, which we'll learn more about next semester. So refactoring just means that the overall code structure has got a bit unmanageable as we've added pieces together. And so we'll then rearrange it. So refactoring is just rearranging the code structure diagram. So methods might be moved out of one class and into another class. Hopefully we won't have to change the method headers, but we might have to do that a bit. And so some pieces of code have to be rewritten. So refactoring often means that we just keep migrating the design to an optimal structure. Whenever there are some suboptimal features appear, then we just go and change the design a little bit. And so the design evolves in small steps. We try and avoid large refactoring, but occasionally we'll have to do that, and everyone in the team has to be involved in that. So see the whole picture. This is everyone is involved. So it's not just the manager who sees how everything fits together, but all the developers see how their little bit of work fits into the final product. So that they're not just focused on their own piece of work, they're also understanding have an overview of everyone else's piece of work. So we end up with some slogans for lean software development: think big, act small, file fast, learn rapidly. So here are some questions. So have a look at these questions, and we'll discuss these questions and any other questions you have at the Zoom meeting next week.